2.1, we're going to talk about quadratic functions. When I say quadratic functions, all right, yeah, what's the first thing that comes to your mind? It has to have an x squared. What's it called? There you go. No, it's just a dash. That's why I always make them arrows, because then y'all think they're negative signs. All right, so a parabola. What does it look like when you graph it? A U. Very good. You learned the parent function is right here. Okay, because I made you memorize that on the 50-point test. All right, everybody with me? Okay, so the first thing that we're going to do is I'm going to put some problems up here, and I'm going to ask you what transformations. Now, I'm going to read you the directions that the book says, because they don't say it like that, but you're going to say, oh yeah, they just want the transformation. They say, describe how the graph of each function is related to the graph of y is equal to x squared. That's a transformation, okay? So, here's the first one. F of x is equal to 1/3 x squared. So, I want you to tell me the transformation. Yeah, out loud. A vertical. What? Yeah, but no, we don't call it a horizontal any, because if it were horizontal, it would be with the x. And by the way, how do I know that this is not with the x? Because dadgummit, it looks like it's stuck on. There you go. Looks like it's with the x, but it's not in parentheses with the x and then the squared on the outside. That's how you know if it's with an x. Okay? So, a vertical, what did y'all say? Compression? That's what it is. A vertical compression of what? 1/3. That's it.
So does that mean it gets like tighter together?
Now, look, listen to me. A vertical compression. That's what happened to me. Alright? Someone vertically compressed me. So, am I going to get skinnier or wider? Wider. If you squish someone this way, they're going to squish out that way. Alright? Stretch. Vertical stretch. I wouldn't count wrong, but I'm just saying compression sounds better. Okay? So, and listen to me, I'm going to tell you this. Do you think that college professors make flash judgments about their students by the language that they use? Oh, yes. Okay? Your language is going to tell that professor, hey, that kid knows what they're talking about, or, oh, my word, what are they doing in here? Okay? So be careful with your language that you use. All right, g of x is equal to 2x squared. That's a vertical stretch. So would it get narrower, wider? There you go. A vertical stretch of what? 2. Always put that number in there. Okay? Always put that number in there. All right, here's my next one. You ready? This is h of x. It's equal to negative x squared plus 1. Now, I want you to give me the transformations in the order that you should do them in. You can't use the word upside down. It reflects. Very good. Is that the first thing you're supposed to do?
No.
Absolutely. The very first thing you should do is reflect that thing over the x-axis, and then you can move it left, right, up, or down, however you need to do it. Okay? So, reflect, over, across, however you want to say that. I like the word reflect better than flip. Remember how we said you can't use the word flip unless you can stand right there and flip. Okay? So reflects over the x-axis. One thought they might, but then they said no. Because this floor is very hard. And it goes up 1. Okay? Now let's look at this one. Yeah, I feel like you probably could get Kane to do it. You most,
right here it does.
that's exactly right. You most certainly do, and the reason is because when does that transformation happen? Last, at the very end. People, if it happened at the first, it'd never change anything. Okay? Think about it. It's on the X. They're weird. They're opposite. If it's the first thing that happens when you put it on the Y, it's the last thing that happens when you put it on the X. Okay, so what are my transformations?
Left two.
Yeah, I usually go left to right first. So I wouldn't count off of that, though. Left 2, down 1, reflects over the Y. Now, we've talked about these before, haven't we? Did you see them on the test? Yeah, and tons of kids missed them, okay? Missed them. Because look what's going to happen. When you go left 2 and down 1, this thing is right here. Everybody agree? When you reflect it over the y-axis, then it goes right here. So what did kids say about the transformation? It went what? Right 2 and down 1. Like, no it didn't. This plus 2 says he went left 2. Okay? And they're like, no, look at it. It went right 2. So, know what you're talking about, people. Alright, everybody okay on that? That's stuff we've kind of been doing all year long, so everybody should be okay on that. I don't see any problems with it. Alright, so now here comes the more difficult stuff. Alright, so y is equal to a times x minus h quantity squared plus k. Y'all remember this from last year? Yes? Anybody know what we call it? The nice name that this is called. Last year we said this was in what form? Yeah, we said this was in vertex form. And remember I told you, I said, y'all, you know it's vertex form because what can you look at it and see? The vertex. Okay, but then I also told you, now next year, they're not going to call it vertex form. They're going to call it standard form. Okay? Standard form. Now, why is that important? Why can't I just keep calling it vertex form? Because guess what the directions are going to say? Put it in standard form, and you're not going to know what it's talking about. Okay? So, what is the vertex of this one? What? What?
H over K.
HK, people. What's the matter with y'all? Y'all, if it's with an X, it has to be an X. Okay? Well, I heard negative H, and I heard KH. I heard all kinds of weirdo stuff. Alright. Now, what about this H? What did you do with him from here to here?
Opposite.
Yeah, you had to change his sign. You're always going to do that on the X. That's the X value, guys. Remember what we say. They're always opposite of what you think. And the K value, what do you do with him?
Exactly whatever.
So keep his sign. Alright. So here's what's going to happen on the test. The first page of the test is going to be these problems, putting them in standard form, and answering some other questions about it. And the test is pink. What does that mean? No calculator. So you're not going to have a calculator. So you can't depend on the calculator to either check your problem or, heck, do the problem for you. Okay? You either know the skills or you don't know the skills. That's a whole page of the test. So if you don't know how to do it, people, you're going to start off your test in a bind. Okay? So I'm going to start off. Their example 2 is a little bit more difficult than I wanted to start off, so I started off really easy, so I'll call mine 2A. And it looks like this. F of x is equal to x squared plus 6x minus 12. All I'm going to do is see if you know how to put this in standard form. Does anybody remember what we call it? Yeah, it's called completing the square. Now, here's the deal, guys. You learned how to complete the square last year in Algebra 2. Okay? You don't remember. But I'll bet you when I do one problem, you'll go, oh, yeah, I remember that. Okay? Now, here's the other deal. At the end of this year, is that very far away? No. Thank you, Lord. Yeah, not very far away. You're going to have to know how to complete the square in order to take the conic sections and put them in the proper form. Okay? So you're going to have to remember this. So don't just go, I'm not going to learn it, or I'm just going to learn it for the test. All right, so here's what we do. Guys, you're going to keep the x squared and the x together, leave you a little space, and then isolate or pull out that constant, that plane number term out here. Now, look what I'm trying to do. The object of the game is to make it look like this. Obviously, this minus 12 is working to be my k, but he's not my k yet. I've got to make a binomial squared right here. So what I'm going to do is I'm going to make a perfect square trinomial. Then I can write it like this. So how do I do that? You take half of 6, which is, square it, and you add it right here. Now, do you always add it? Why? What if this were a minus sign right there? Because you're squaring it. So even if this is a minus sign right here, when you square it, it's always positive, so you always add it. PreAP. Oh, then we would have a lovely fraction, which is not a big deal because that's a 6th grade skill, right? There you go. All right, but here's the problem. You've changed the problem now, right? Because I just went plus 9, so now it's different. Yeah, so whatever you do in here, you have to undo out here. So I'll subtract 9. Now I haven't changed it.
I remember this.
There you go. How do I write this as a binomial square? Well, it's square root of the first. Keep this sign. Whatever this sign is, you keep it. The square root of the last, which should also be half of this number. That's a good check right there. Okay? And then quantity squared, and then what's negative 9 and negative 12? All right, what's my vertex? What? Negative 3, negative 21. Very good. Okay, now I'm going to let you try one. Now, what am I going to do to this one? Well, we're going to do another one. I'm going to make it a little more difficult. Okay, this is actually the example 2 in your book. Okay, and it looks like this. F of x is equal to 2x squared plus 8x plus 7. I'm going to make it a minus 8x, just because I don't want everything to be a plus. Okay. What's different about this one? There's a 2 in front of the x squared. So if you remember the rules for completing the square, you cannot complete the square unless the coefficient of the quadratic, that's the number in front of x squared, is 1. Okay? So you have to, now listen to me, let me talk to you about this. Some kids just want to divide the 2 out to get rid of it. Yeah, because what is that 2 telling you about the parabola? It's a vertical stretch. That thing's narrower than the parent function. If you divide it out, yours is not going to be the same, okay? So you can't just divide it out. All right, so we pull it out, but you only pull it out of the x stuff. Don't pull it out of that plane number. So then I'll get x squared minus what? 4x, and then you got a plus 7 out here. Now this is what I taught my kids. We'll see if they remember. Anytime you take something out, I told you to draw the rainbow, because that's where the problem comes in. This is where the careless mistakes are made, okay? I always taught you to use a different color pen because you want it to stand out, or make your line or something really dark so it stands out, okay? Now here's why you have to do that. When I start to complete the square, what's half of 4? What's 2 squared?
4.
So I add 4 right here. Yeah, you didn't really add 4, guys. The distributive property said you really added what? 8. So what do I have to do out here? There you go. So now I'm going to have 2 times what? X, keep the sign, minus square root, which is half, quantity squared. What's 7 minus 8? What's my vertex? 2, -1. Very good. Very good. All right. So here's the deal, guys. There's going to be 3 problems on the current page, but they're going to ask you a lot of things. Like they're going to say, put this in standard form. Tell me what the vertex is. Tell me what the x-intercepts are, and we'll do some of those tomorrow. We're going to do one more. Okay, one more. Open your notebook back up. I know. Well, I didn't say. I'm finished. I have like 5.5 more minutes left. Don't be pushing me. All right. So here we go. I like to use all my time wisely. 2x squared plus 5x plus 3. Okay. So I want you to do the first step. You do the first step. That's all I want you to do. I mean, if you can do the whole thing, jump off there and do it. But if you can't, just do the first step. Okay, so you have to take out the 2. You're left with an x squared. Here's where some kids ran into a problem. Factoring is the same thing as dividing. So, y'all, that's just 5 divided by 2. Now, don't be Becky Davis and say, I absolutely refuse to work with a fraction, so I'm going to write that as 2.5. No, people, you're just going to make your problem more difficult, okay? So then there's my plus 3. I'm going to draw my rainbow, okay? Now I'm going to take half of this. Oh, man, it's a fraction. So instead of dividing by 2, what am I going to do? Multiply by what? What is 1/2 times 5/2? Notice that when it's a fraction, I write it down on the edge of my paper. It's harder for it to stick in my brain. It's a lot of stuff. Now I have to do what to that? Not double it. Square it. Okay? When you square it, you square the top and the bottom, and what do you get? Okay, so I'm adding 25 over 16. But did you really add 25 over 16? Okay, you added 2 times that. Now watch what I'm going to do. Now this is so much easier. You should do this. Can't I reduce that? Yeah. See, 2 goes into 16 8 times, so what's the answer? 25 8. So that's what I'm going to subtract out here. Okay? That's okay. We don't have to. We have pencil and paper. We don't have a calculator. Square root of the first. Keep the sign. Y'all look, the square root of this, it's written right there. That's another reason I write it down. It's 5/4. Quantity squared. What do I have to have right here? What is the common denominator between 1 and 8? 8? What do I have to do to this? Multiply by 8, so I multiply the top by 8. 3 times 8 is 24. This is already over an 8, okay? So don't work on him. What's 24 minus 25? -1/8. What's my vertex? Perfect. Okay. Everybody okay so far? All right, that's all we're going to do today. That wasn't too bad.